Hey everyone, I am Abhisheka from Team Vertexa, and I'm excited to present to you our Smart India Hackathon project, Sarthi, an AI-powered decision support dashboard for Indian railway controllers. 22,000 trains, 68,000 kilometers of train tracks. Right now, Indian railway controllers are performing mental gymnastics that no human can sustain. They are making life and death decisions based on incomplete information, leading to billions in delays. This is where we step in. Sarthi is an AI co-pilot for railway controllers. Our system sees the railway network in real time and produces conflict-free schedule using advanced mathematical calculations. Compare it to India's current railway system coverage, which only covers about 1400 kilometers of tracks. We provide optimal decisions which Indian railway controllers can not only trust but also understand, and we are improving the network capacity about 25% without installing a single new track.
Today, I'm excited to show you Sarthi, a railway network builder and interactive web application that allows you to design, visualize, and optimize railway networks. This tool is perfect for transportation planning, operations research students, or anyone interested in railway logistics and path-finding algorithms. As you can see, the interface is divided into three main sections. On the left, we have our tools panel with various controls. In the center, there's a canvas where our railway networks are displayed. And on the right, we have preset network configuration that we can use. Okay, so let's start creating a complex railway network with the help of these tools given on the left side. We will select the stations tools to select multiple stations. We have created now that we have created multiple stations here, let's connect them with the help of sections tool. Let's connect section one with station one with station two. Now we use section two to connect station two with station five and with station five with station three and station three with station four with station three. Okay, so as you can see on the right side, we have a multiple network presets. So let's add one network preset here. We have added a diamond crossing preset here. So let's move this a bit here. Okay. Now let's connect station one with West 9, station 4 with station 2. So in this way, we can create a complex railway network on the canvas. And after creating the complex railway network, we can now what we have to do is add a train on this network. Okay, so by clicking on this add train tool, we can add a train here on the network, and let's add two more trains. Okay, so as you can see, there are multiple properties that we can alter. Right now, I've clicked on the station one, so we can change the station one name here, and there are these sections showing here the section that connect multiple stations. So we can also change the distance between the section. Right now, the distance between these two stations is 10 kilometers. We can also change this to let's make it 20 kilometers. Okay, so now it's 20 kilometer. This is the maximum allowable speed for the particular section. So let's make it 80 kilometer per hour. We can do this for all the sections here, and this is the bidirectional. We can check this thing to make this particular path bidirectional. Okay, so this is for the sections part. This is the network overview right now. This is giving a basic overview of the network that is right now showing us in the canvas. Like there are 10 stations, section export is 20. There are 3 trains that we have added on this network. And we can also alter the properties of the trains. Like these are the allowed sections on which this train 1 will move, like section 1 to section 10. This is allowed to move from section 1 to section 10. Same for train 2 and same for train 3. 3 here. So we can change the properties of train 3 here, like maximum speed of a particular train. Its start station. Now let's make it to station 3 for train 3, and end station, let's make it West 9 as the end station. Okay, so as you have seen, we have created this network here. Suppose if we have a network pre-built somewhere, we can also import that network on this canvas, like by clicking on this import JSON button and select the network that we want to import on this canvas. So in this way, that particular network will be imported over here. So as you can see, this network is imported. And this has it has multiple properties if it has 10 trains moving on there are 10 trains moving on this particular network. There are 7 stations, 12 sections, and yeah, now let's compute a path for trains. Okay, now that we have built a railway network, let's see it come to life. This is the advanced train network simulation, real-time train scheduling with bi-directional tracks and performance metrics. The simulation includes real-time train scheduling, collision avoidance, delay tracking, and performance analytics. So let's start with the interface overview. Let's quickly tour the simulation interface. At the top, we have a control panel with 3 main buttons: play, stop, and reset. We can hide and show the panels as we wish, and we can zoom in and zoom out, and we can also adjust the speed of the simulation. Now in the left pane, we have the network layout, which lists the number of stations, the number of sections, and the bidirectional sections we have. And then we have track sections in the left pane. Here we can see all the sections which are present in the network. Like center to north, the distance is 15 km, max speed is 120 km per hour. Similarly goes for all the sections. And in the left pane, the next thing we have is train status. Here we can see that mainly train 1 is waiting, train 2 is waiting, and there are some running trains. Now in the center part, we have the canvas in which we can see various sections and stations. When we run the simulation, we can also see the trains. In the right section, which is the most critical section of this simulation, we have the performance metrics, which is total completion time, average delay, success rate, and total delay.
We have the active trains which will be running when we start the simulation, and this active train is dynamic, while the trains listed here is a static which will show the current status of each train. So let's start the simulation. Okay, so let's start the simulation. We can see there are trains which are moving with the speed. Multiple trains have started to move. Here we can see the active trains, and in the train section we can see the status of each train. Some trains have completed their paths. We can see train 2 and train 6 are moving on the same section. Let's take a pause here. The train 2 and train 3 were moving on the same section, and they were maintaining a safe distance by the use of dynamic headway, which have used in mixed integer linear programming. Let's continue. Okay, so we can also adjust the speed of the simulation. The trains are simulated to minimize the total average delay so that we can optimize the train scheduling.
This project bridges the theoretical operation research and practical transportation planning for providing an accessible visual tool for exploring complex scheduling problems. It demonstrates that railway optimization involves balancing multiple competing objectives and shows how network topology, speed limits, and scheduling policies interact to affect overall system performance. The success rate of 80% and 42.8 minute total delay in the baseline scenario highlights opportunities for optimization and provide concrete metrics for measuring improvement strategies.